Just solving one of the examples. So a rubber ball of mass 5 grams, 50 grams, sorry, 50 grams falls from a height of 1 meter. It rebounds to a height of 0.5 meter. Find the impulse and average force between ball and the ground. If time for which they are in contact was zero point 0.1, I remember just confirm it is 0.1 second, 0.1 second. So you can say it 1 into, sorry, 1 into 10 raised to minus 1 seconds. So like that it is. So let's go ahead. So how will be forming? Now let's go for move for some a type of diagram there. Let's go for a diagram there. If you'll just just a second, we'll go for directly. I'll take a diagram for this. If you'll observe this diagram, the ball, rubber ball from mass of 50 grams. This is rubber ball. It is mass having 50 grams. So 50 grams there. So if you convert, that gets converted into 50 by 1000, that will be 0.5, right, kg. So 0.5 kg. So after that, what you'll be having, it is coming down. It is coming down there. We can observe here. And it is reaching till point B now. Let us assume it reaching point B. So this height is 1 meter. So this is what they have given, that is 1 meter. Now another question, what it rebounds to height of 0.5 meter. Rebound, it is coming back here, rebounding here. Let us assume it rebound 6, that is 0.5 meter. This is zero point 0.5 meter. So as usual, this is 1 meter, you can say 100 centimeters here. So I'm using here 1 meter 100 centimeter, converting the 50 centimeter into 0.5 meter, or zero point 0.5 meters into 50 centimeters, but just a comfortability. So this is what the diagram is asking here. Now next step, this is for ball. This is what I'm taking for a ball A there. So we'll be having V square minus U square, that is equal to 2GH, the formula. We are using this formula for that. So U square, that is the initial velocity. Initial velocity, that will be your 0 there. Final velocity, so now here at point A it is 0 there. So it will be 0. 2 times G is 9.8, 1 will be your 1 meter distance. So from that you will be getting a value V is equal to 19.6 meter per second. That is the velocity what we are getting for ball A now. Remember, that is what we are getting for ball A. Now let's U dash be the velocity of rebound of a ball here. So we are assuming U dash the rebound of velocity, ball coming down, going up, and when it is coming up, it is going to stop for a fraction of second. So final velocity will be 0 there. V dash final velocity is 0. The distance is 50 centimeters, that is 0.5 meters. As usual, G, it is negative against the gravity, So we are taking G as minus 9.8 meter per second square. So V dash square, same formula, V dash square minus U dash square to AS. Many times I'll be preferring A is replaced with G, A is replaced with G and S is replaced with H. So you can say that is a 2GH like that. So V square minus dash square minus U dash square will be 2GH. So final velocity, here the final velocity is 0 here. Final is 0 here velocity, because it is ball is going to stop for a second and then it is again going to come back. So next rebound, that will be, that is not required here. So it will, that final velocity, it is going up, stopping for the second, 0 minus U dash square. U dash square will be is equal to into 9.8 into 0.5. Similar. So you'll be getting this value. So velocity for the rebound velocity, that is equal to under root of 9.8. So if you'll observe this one, impulse. Now impulse is nothing but change in momentum. So mv minus of minus mu, it is rebounding. So it is a negative. So we'll be getting mv plus mu dash. So m into v plus u dash. So mass, that what we are having, actually it is what mass they have given. Let's go for the mass there. What is the mass there? Oh, 50 grams here. Okay, we'll work with 50 grams there. So 50 grams, so that will be 0.5 multiplied by v plus u. You will be, what velocities we have got here. U dash is what we are getting, under root 9.8 and under root 19.6. Using the calculators or calculate, you can calculate using your log table. And if calculator allowed, you can go for that. Plus 9.8. So you will be getting here this part 0.378. That is the answer you will be getting here. So meters per second. So here the impulse, that will be meter seconds. Newton second, what we have, it is a Newton second there. Newton second. Okay. So impulse, change in momentum, mass into velocity. So this is what the final answer we are getting. Now we want to calculate the average force. What is the next part they are asking?